Students, the today topic of discussion is the module 3 of mechanics of solids. That is, we have to study about shear force and bending moment. That is, whenever a beam is loaded, a beam, you may have an idea about what is a beam. Beam, let this be a beam, and there are two supports. And whenever we are loading this beam, there can be different type of loads. I will be explaining this. Then there can be two types of failure that can occur in the beam. That is, either the beam can fail by bending. It can bend in this way. Or again, if this is the beam, and since vertical load is being applied here like this, then one is by bending, another is by it can separate into two halves vertically like this. It can fail, or from any point. So these are the two main possible ways in which a beam will be failing. So while designing a beam means we will have to find out the dimension of the beam. What is a beam? A beam means it is a structure which is a structural element which is supporting the slab. Okay, if I'm having a 3D structure like this, this is a support, so I'm marking here. So here, this rectangle portion, it is the slab. So the load is coming in the slab, and that load is distributed to the beams, and that load is again distributed to the column, and from that column it is going into the foundation. Like this foundation will be there, and again it will be going into the soil. So this is a major way in which the load is transferred from a slab to a soil. So designing an element means we are finding out what is the size. For example, this is the beam. Then we have to fix out what will be the size of this beam, as well as what are the reinforcement should be given. As you all know, why we are giving reinforcement to a beam? Reinforcement is given to a beam to take up tension. Okay. So here in this figure, you can see there are different beams are here. So here you can see there is one. Here is a beam. Here is another beam, and another beam. Three beams are here, and you can see here. That is, this is a normal beam. Okay, or just understand this. Here you are having some horizontal reinforcement like this. That is, in the top and bottom there is horizontal reinforcement, and you are having vertical reinforcement like this. Okay, so this horizontal reinforcement is mainly found out based on the bending moment, and this vertical reinforcement, it is known as stirrup, and that is for taking up the shear force. So for any beam, when a load is applied in a beam, there can be mainly two modes of failure. There are different modes of failure will be there, like torsion will be there, like that failures will be there, or lateral loads will be there. Due to earthquake, there can be failure. So now I am only considering two types of failure. So while designing any structure, the first important thing you have to understand is that first thing we have to understand what are the different modes of failure, how it can fail. Only by knowing how it is failing, we can give provisions to prevent that failure. So in order to prevent that failure only, we are giving these type of reinforcements. Okay, this is a way in which you have to think. So when you are having a structure, first thing you have to know is what are the loads coming in a structure. Loads, and how that loads will be affecting the structure. The affecting structure means how it is causing failure. So in a simple beam, there are mainly two types of reinforcement, vertical reinforcement and horizontal reinforcement. This vertical reinforcement is based on the shear force and horizontal reinforcement is based on bending moment. So this is the importance of this topic, that is shear force and bending moment. So here we have to find out the shear force in a beam. By doing one or two problems you will be able to understand how to find out the shear force and bending moment, and you have to draw the shear force and bending moment diagram. So this is a thing which we have to study in this module. Okay. So before going into the shear force and bending moment, the first thing, one or two things you have to understand, that is, you may be knowing. First one, it is supports. Supports. That means for a 2D, consider a just 2D point. Let that point be x, y. Considering a point in 2 dimension. This point can move in. It can move in vertical direction. It can move in horizontal direction, or it can rotate. That is, for a 2-dimensional point, it can have 3 types of motion. That's a vertical motion, horizontal motion, and rotation. Okay. So, and for a 3-dimensional body, I am considering a body like this. It is having a point, that is x, y, z. Here it can have a vertical movement, horizontal movement, then movement in the other horizontal mutually perpendicular plane. Then it can rotation in the that is, can have horizontal movement y, x, y, z direction. Then it can have rotation in different planes also, in x, z plane, x, y. So in a 3-dimensional body, it can have 6 possible movements. 6 possible movements. Here it can have 3 possible movements. So our discussion is mainly on the 2-dimensional point. So here, so considering this two-dimensional point, so here, okay, we can, so a body can freely move in vertical direction, horizontal direction, and rotation. And whenever I am preventing this motion, if I am preventing a motion in this moment, if I am preventing this point from moving in vertical direction, I am preventing this. I am not allowing it to move. Then what will happen? Then it will exert a force to the body. That is, by Newton's law, when we are restricting a motion, then what will be happening? An equal and opposite reaction will be there. So, by restricting this, if I am restricting a vertical motion, then there will be a vertical reaction will be there. I am marking it as a VR or RV, like that. If I am preventing this horizontal motion, there can be another reaction. Horizontal reaction can be there. And if I am preventing this rotation, there can be a moment. Okay, moment in a point. So, the 3 possible reactions that can come in a two-dimensional body is a vertical reaction, horizontal reaction, and a moment. So these are the 3 possible reactions that can happen in a body. Now, so based on this, we can have different types of supports. Okay, the first one is it is a simple support. Okay, that is, if I am having a wall like this, a brick wall is here. I am having a brick wall. I am keeping a beam, just keeping a beam like this. Okay, a beam is kept. It is not having a this is a concrete, this is a brick, and just keeping it in the above the wall. Then this type of reaction, it is known as a simple reaction. Simple simple support. That means here there will be only a vertical reaction will be there. This is simple support. Now the second one it is, simple support. Second one it is a roller support. Roller support. That is roller support means that is, for example, I have said earlier that there can be a vertical movement, there can be a horizontal movement, or there can be a rotation. So these type of movements can be there. So in a roller support means I am having a movement only in one direction. That is, for example, in the case of a gate, sliding gate, we are having a movement in only one direction. So such a point is known as a roller support. That is, if, for example, in the case of shutters used for shop, the shutters used for shop will be moving in the vertical direction. That is movement in only in vertical direction. So roller can be of two types, horizontal and vertical. Horizontal and vertical. So there can be two types of rollers, and it is mainly denoted. This vertical roller, it is denoted in this way, and a horizontal roller, it is denoted like this. Okay, horizontal roller and vertical roller. Okay, now the next type of support, that is, what is the next type of support? It is a hinge. That is a support that is in our door frame. You know that a door frame is there. The door shutter, it is fixed to the door frame, and you can imagine a door can move in a direction. It cannot move vertical or horizontal. It can only rotate. That is, here in a roller support there can be horizontal or there can be only a vertical. Hinge means here, this is the denotation of a hinge. Here there is vertical and horizontal reaction. It is allowing what? It is allowing rotation. So rotation is allowed. Here the moment is equal to 0. Here the moment, in the case of horizontal, here the moment as well as the vertical, it is not equal to 0. Sorry, horizontal, that is again it is horizontal is equal to 0. Here horizontal is equal to 0. It is allowing horizontal reaction. Here vertical reaction will be 0. Here the moment will be 0, because here there is vertical reaction and there is horizontal reaction. And the last type you have to know, it is the fixed support. Fixed support means that is a support, it is mainly denoted like this, and here that is like this. So that means I am fixing a beam to a wall like this. Okay, beam is fixed. Here this point, it is not allowing any type of movement. That is, vertical movement is prevented, horizontal movement is prevented, and rotation is prevented. Okay, all the motions are prevented. So here there is a vertical reaction, horizontal reaction, and moment. So all these are present. Okay, so by summarizing, we can say that based on the supports, that is, if I am having a support, then the reactions, and the first one, it is a simple support. Here the reaction can be vertical only vertical reaction is there. Second one, it is a roller. A roller can again be two types, that is a horizontal roller and a vertical roller. In a horizontal roller means it is like this. This is the symbol. Vertical roller means it is like this. Okay, in a horizontal roller, there will be vertical reaction and moment. Here a vertical reaction. Horizontal roller, there will be vertical reaction moment. The other one will not be there. Then second one it is, and one more thing is a roller. It is having a vertical reaction. Here it will be having vertical reaction, but there is no horizontal reaction. Here is only vertical reaction. Here in the horizontal roller there will be no moment. Okay, that is a small change is there. Horizontal movement will not. Sometimes it can. Okay, and the next one it is a hinge. The hinge support is also known as pinned support. It is having vertical and horizontal reaction. And the last one it is a fixed support. That means it is having vertical, horizontal and moment is there. Okay. Now based on this types of moments, now it is the type of beams. Types of beams. The first one it is simply supported beam. Simply supported beam. So simply supported beam means I am having a wall like this. I am keeping a beam, just keeping the beam like this. Okay, I am constructing a wall and above I am keeping. This is a simply supported beam. Another type of beam it is a beam which is having a hinge at one end and a roller at other end. This is another type of beam. That is a hinge at one end and a roller support at the other end. Then the third type it is a cantilever beam. Cantilever beam. What is meant by cantilever beam? Cantilever beam means I am having a support at only one end. A support is there and it is only at one end. Just a minute. So cantilever beam it is like this. It is a beam is here and it is having a support at only one. That is cantilever beam. And the last is next type of beam it is fixed beam. Fourth type it is fixed beam. Fixed beam means I will be having a fixed support and the beam will be like this. Both sides there will be a fixed beam. Fixed supports will be there at both the sides. Fixed. Here will be also a fixed support will be there. Another type it is propped cantilever beam. Propped cantilever beam. Propped cantilever beam means one side it will be fixed and other side, other joint can be a roller or a hinge. Okay. And the next type it is the fifth one, and the next type, the sixth one it is a continuous beam. Continuous beam. Continuous beam means a beam, there can be a support at one end. So there can be a beam will be like this. It will be having supports at more than two supports will be there. That is a continuous beam. Then another type it is overhanging beam. So from the figures itself, I will be the notes will be also given. From the figures itself, you will be understanding. That is then overhanging beam. Overhanging beam means, for example, I am having a beam like this. It is having a support at one end and an intermediate support is there. So here you can understand this is a overhanging. Similarly, another beam. You can understand from this. That is here there is no support. Here also there is no. This is a single overhanging beam. This is a double overhanging beam. So these are the types of beams. So first we have looked into. So this you can just see here. That is type of supports. It is a simple support. Then there is a simple support, roller support, hinge support, then fixed support. So it is as I have said. Then type of beam, simple beam, then beam with a hinge, and the figures itself: overhanging beam, cantilever beam, propped cantilever beam, both ends are hinged, continuous beam, etc. So these are the types of beams. And the next one it is the types of load. What are the different types of load that can come in a beam? Types of loads. Okay. That is types of loads. First one, it is a concentrated load. Concentrated load. That means a load. For example, I am having a beam like this. I am having a load at one point. Load is acting at, that is meant by concentrated load. The unit of this load is in kilonewton. The unit you have to understand. It is kilonewton. Kilonewton or newton or kilogram force, like that it can, the unit be. Or it can be in kilogram, like that. The next type of load is uniformly varying load. Uniformly varying load is there. Then next one is uniformly distributed load. Uniformly distributed load. This is UVL and next is UDL. UVL and UDL. That is, for example, first I am saying about the uniformly distributed load. That is, I am having a beam like this. Then there is a load which is in the shape of a rectangle like this. Or it can be, in some textbooks it is represented like this. The load is acting like this. It is in a rectangular shape. This is UDL. And the unit is mainly, it is kilogram per meter or Newton per meter or Newton per millimeter. That is a unit. That is uniformly distributed load. Now it is uniformly varying load means I am having a beam like this and there is a triangular shape type of load. Triangular shape. That is meant by uniformly varying. Varying, that is a word meaning, varying. That is in the shape of a triangle. Again, the unit is kilogram per meter or Newton per meter. So these are the three types of loads that can come in a beam. That is normal type of loads that can come in a constant load, uniformly varying load, uniformly distributed load. Okay. So far now we have discussed about, we have started with what are the types of supports, what are the types of beams, and what are the types of loads. So these are the things you have to do. So mainly it is shown here. This is a concentrated load, this is a uniformly distributed load, and this is a uniformly varying load. So you have to understand about these things. And now we have to understand how to find out the shear force and bending moment. So that is the main point of discussion that is going to take we are going to study. So here you have to find out the shear force and bending moment in a cantilever beam, in a simply supported beam, and in a overhanging beam. So you have to study about how to find out the shear force, I am represented as SF, and bending moment, shear force and bending moment in a cantilever beam, second one in a simply supported beam, as a simply supported beam, and third one in a overhanging beam. So these are the things we have to study, and here you have to find out the bending moment and shear force, bending moment and shear force, and you have to draw the bending moment and shear force diagram. So this is the way in which you have this is the thing which you have to study, particularly in this module. So for an introduction only, I have introduced you to the type of supports, type of beams, and type of loads. Okay. Now let us look into how I can find out the shear force and bending moment in a cantilever beam. So now we will be studying about cantilever beam. Okay. So the shear force and bending moment, that is shear force and bending moment in a cantilever beam. Okay. Now we are going to discuss about the shear force and bending moment in a cantilever beam. how we can find out this shear force is the topic we are going to discuss now. Shear force and bending moment in a cantilever beam. So I am considering a cantilever beam. What is meant by cantilever beam? Cantilever beam means it is a beam which is having a support at one end only. Okay. The example of a cantilever beam, it is a sunshade. The sunshade, it is an example of a cantilever beam. Okay. So here, so I am having a beam. So this is a beam. Is here. A beam is generally represented by a simple line. Now it's a beam. Now I am applying a load here, W. A load is applied here. A concentrated load is applied here. First of all, I have to find out the shear force. So shear force means in order to find the shear force, I am just considering 2 points A and B. Okay, I can consider another point also C. So shear force means what is a vertical force at a section is known as shear force. Now let us understand. Now there are 3 points. So first of all, I have to find out what is the shear force at a. For a cantilever beam, either I can find out from this side or it can find it from any side. Okay, so in order to find the shear force and bending moment, for a cantilever beam, we can start from the free end. This is the fixed end. It is the fixed end, and this is the free end. Okay, for a cantilever. So the basic step is that first of all we will start from this end. Okay. Now I am considering this point B, that is shear force SF, shear force at B is equal to, what is meant by shear force? Shear force means is the vertical force. So what is the force at B? It is W itself. Okay, that is the force at B, that is shear force. Now I am considering point C. I am now considering point C. Okay, now here I have to find out the shear force at a point C. So here I am having an option. Either I can take the loads. First of all, I am considering a section like this. A line is drawn. I can either take the forces in the right side or either in the left side. So here I am looking. Here from C, I have taken a section. Then I am looking to the right side. What is the force there? W. No other force is there. So what will be the shear force at C? It will be W itself. Okay. Now shear force at A. Again shear force at A. Again this is the section. So I am considering right or left. To the left there will be no load. Only right there is load. So so here the shear force is again W. So the shear force is always W. If I am taking a section here also, I am taking an arbitrary and a sample section XX like this. How can I the shear force means it is the sum of the forces to the right or left of the section. I can either take the forces to the right or I can either take the forces to the left. Okay, so by considering some more problems, it will be easier for you. That is, and one thing is that here it is a shear force at a section of a beam is a force that is trying to shear off the section and is obtained as the algebraic sum of the forces acting normal to the axis of the beam either to the left or right of the section. That means if I have to find out the shear force at this point C, I can consider the shear force either to the right or, for example, consider this beam. A beam is there and a force is acting here. A force is acting. So here I am considering left of the section. What is the force? It is having a vertical reaction will be there. So either you can consider to the left or right of the section. So it will be more clear when we are doing some problems. Okay, then I will explain this once again. Now the sign convention. Next important thing is that you have to know the sign convention. This is a sign convention which is followed in some textbooks. Will be having another sign convention. So I am following now. In our discussions will be based on this sign convention. That is here. Here you can see that this is a section, and if the shear force is to the down to the left of the, if I'm having a beam like this and I am considering a section, okay, to the right, and if the force is the net force is to the down, or if I am considering left, net force is to the up. then this is considered as positive. And if in the vice versa, if this is a section, if this force is to the up and this is to the down, this is known as, this will be negative. Okay, so this is the sign convention which we are mainly following. And in the case of a bending moment also, bending moment we will discuss after the shear force has been done. We will be moving into the bending moment. Okay, so I just do not understand some more about this. We will have a numerical problem that will be easier for me. So here I am considering a beam. Now here there is a load 10 kilonewton and there is a load of 20 kilonewton. Okay, this is a cantilever beam. Here it is a free end. Let it be A, B, C and D, and let the distances be 1 meter, 2 meter and 1 meter. Okay, so this is a beam. Total length of the beam is 1 plus 2 plus 3 meter beam. 3 meter cantilever beam is there. I have to find out the shear force. Okay, I have to find out the shear force. Now first step is step 1. Here the step is, first you have to start from the free end. That will be easier. So from this end I am starting. So first one I am writing shear force at D. So I am considering this section. What is the shear force? Is there any force here? No. The force is only at a distance from 1 meter. So shear force at D is equal to 0. Now I am coming to C. Shear force at C. What will be the shear force there? It is, what is the shear force at C? It is 10. It is to the downward side. Therefore, as we have earlier said, if the section I am considering, it is the force to the downward side. If I am considering to the right, that is taken as positive. So I can write positive 10 kilonewton. Now again, I am considering another section here. An arbitrary section is considered. What is the shear force at this point? Okay, let it be X. That point be XX. Now either I can consider the forces to the left or to the right. I am now taking only the forces to the right. For a cantilever beam only I am taking like this. So what are the forces here? Only 10 kilonewton. So what will be the, that is shear force at the XX section will be, what will be that? To XX section you can either take a right or left. So I am taking only right. Here I am taking right of the section. What is the forces? Only 10 kilonewton is there. Okay, so that is between the C to B, the shear force will be common. Now shear force at B, what will be the shear force at B? It is, I am considering a small section near to this. I am taking the load to the right or left. I am taking the right. Now I am considering right. So what are the forces acting? 10 kilonewton is there, 20 kilonewton is there. So what will be that? 10 plus 20 plus both are in the vertical downward direction. That is total will be 30 kilonewton. Okay. Now again I am considering last point is shear force at A. That is this point. So what will be the shear force at that point? That will be again 20 plus 10. That is 30 kilonewton. So I have found out the shear forces at the different points. Now I have to draw the bending moment diagram. Sorry, the shear force diagram. So I am here. So here I am taking, this is the beam. Beam is there. So here we are having 10 kilonewton. Here we are having 20 kilonewton. So I am just drawing a baseline is drawn. Okay. Now from this, the shear force at this point is 0. 0. At this point, what is the shear force we have taken? It is 10. It is positive. So in the upper side. So here it is 10. And while considering these points, at this point again it is 10. And at this point B, what is the shear force? 30. So it is there is 30. Again that is same here also 30. So I can join like this. That means, so this is the shear force. It is positive only. This is the shear force. Here it is 10 kilonewton and here it is 30 kilonewton. So this is my shear force diagram. So what I have started, I have started from the right free end. From the free end I have considered and drawn to this side. Again, for example, another problem we will consider. So by understanding some problems, you will be getting into this concept very easily. Again, I am having a load like this, 10 kilonewton here. Then I am having a 20 kilonewton. Then again a 30 kilonewton. Like this, lot of loads are there. Let it be 1 meter, 1 meter, 1 meter. Let it be A, B, C, D. Now, shear force at D. What is the shear force at D? It is downward, therefore I can positive 10 kilonewton. Next one, shear force at C. What will be that? 20 plus 10. 10 plus 20, that is 30 kilonewton. Then shear force at B. What will be that? 20 plus 10 plus 30, that is 60 kilonewton. Again, shear force at A is also 60 kilonewton. So how can I draw that? I am drawing a baseline. Here it is, first one it is 10 kilonewton. This 10 kilonewton, it is constant up to this point. Then again a 20 kilonewton is applying. The total will be a 30 kilonewton. Then again up to this point it will be coming. Again it is taking 60 kilonewton. And likewise up to here. So here it will be 10 kilonewton. Here it will be 30 kilonewton. And here it will be 60 kilonewton. So this is the shear force diagram. Shear force diagram. So here we have considered only what load? For a concentrated load. So for a concentrated load, you can understand that from this point you just see the from C to D the shear force is at any section from here, that is at any section it will be 10 only, because there is no intermediate load. And again, so for a concentrated load, the shear force diagram will be a constant line like this. Okay, that is a shear force diagram. Now let us consider another type of load. That is again a cantilever beam is here. I am having a load like this. What is this load? It is uniformly distributed load. And let that value be 10 kilonewton per meter. So let the length of the beam be 2 meter. A, B and C. I am considering another point C. Now first of all I have to find out the shear force. So shear force at B, first one, I am starting from this end. So here it is kilonewton per meter. That is, if for a UDL, how can we find out the load? The load will be distance into that value. So at this point, the load is only at that point. The meter, the length will be 0. That is 10. The load will be 10 kilonewton per meter into length is 0. Therefore, shear force is 0. Now considering this point is C. An arbitrary point is C is chosen. Let that be at a distance of 1 meter. Okay, 1 meter. Then shear force at C is equal to 10 kilonewton per meter into what is the load distance? This is the distance. So either I can consider to this right or to the left. So here it can be 1. That is 10 kilonewton per 10 kilonewton. So that is the shear force at C. Now again, shear force at A. What will be the shear force at A? That is, I am considering to this side. That is total intensity of load is 10 kilonewton per meter into 2 meter. That is 20 kilonewton. So this is the values. So if for this I am drawing a graph like this. Here we have obtained it is 0. Again, at the point C we have obtained it as 10, and here it is obtained as 20. And how can we join this? Here in the case of you concentrated load, we are joining by straight line. But in this case, you just understand here, if I am taking a section at a point like this, at a 0.5 meter, I am taking a section. What will be the shear force at this point? I am taking the load to the right. Okay, shear force, let that be D. Shear force at D is equal to, what will be the value? This 10 kilonewton into 0.5, that is 5 kilonewton. So at this point it is 5. So this here the load is increasing linearly. So we have to join this by a linear line like this. Okay. So this will be the shear force diagram. So the last here it is 0 and here it will be 20 kilonewton. And these values also, if you can write, it will be 10 kilonewton. Here it can be 5 kilonewton like that. Okay. So just understand another thing, that is here. So I am having a beam like this. Again, I am having a concentrated load and an UDL. Okay, this is 10 kilonewton. Here let the length, this is 1 meter, 2 meter and 3 meter, A, B, C, D. So first of all, I am finding shear force at D. I am starting from this end. What is there is, since there is no load at this region, it will be 0. Shear force will be 0. Shear force at C. What is the shear force at C? It is 10, positive 10. Then shear force at B. I am considering this section, shear force at B. What will be the force? I can either correct to the right or left. I am considering right. So what are the forces it is having? 10 kilonewton is there. Again another it is there, that is let this be 5 kilonewton per meter. Let this load be 5 kilonewton plus 5 kilonewton per meter into 0. 0 because it is only to this end there is nothing. Therefore again at B it will again be 10 kilonewton. Okay. So B again 10 kilonewton. Then what is the shear force at A? This you have to understand. Shear force at A is equal to, this is a section I am considering to the right. So just right, you can right of the section. So what are the loads? A 10 kilonewton is acting to the down. So positive 10 plus again what is happening? A UDL is there. And what is this value? That is load into, that is a load intensity, that is 5 kilonewton per meter into distance is into 3. That is 10 plus, what is this value? 5 into 3, 15. So that is 25 kilonewton. So at D it is 0, at C it is 10, at B again 10, at S it is 25. So I am drawing this figure, I am drawing a baseline. At D it is 0 again. Now I am considering just drawing the guidelines for that, so that it will be easier to mark. At C what it is? 10. So I am just marking 10. Again at B, again it is 10. And at last it is, what is 25. So how can I join this? Here there will be no join. So from here only it will be starting. Here there is a constant. And again here there will be a linear. Okay. So this will be the shape. So this will be our shear force diagram. So here the value will be 10 kilonewton. And here the value will be 25 kilonewton. Okay. So, and again another problem. I am considering a cantilever beam like this. Okay. So I am having a UDL at the starting. Then I am having a load like this. Okay. Let it be like this. Now let it be A, B, C and D. Let this value be 10 kilonewton per meter. Let this be 15 kilonewton. And the distances, let it be 2 meter, 1 meter and 1 meter. Okay. Now I have to start from this end. What is the shear force? Since this is a UDL, if I am considering to the right, this point, what is the shear force at D will be 10 kilonewton per meter into distance is 0. Therefore, it will be 0. Then shear force at C. What is the shear force at C? It will be, I am considering to the right of the section. I am just writing here right. Okay. This right and left will be useful when it, you will understand it more when you will be taking the simply supported beam and overhanging beam. Then it will be of more relevance. Okay. You will understand that. So at C, what is the load? It is 10 kilonewton into kilonewton per meter into distance, that is 2, that is 20 kilonewton. Then what is the shear force at B? That is again, that shear force at B means at this section, that is again there is 15 plus again 10 into, what is the here? 10 into 2, that is 10 kilonewton per meter into 2, that will be leading to kilonewton, that is 20 plus 15, that is 35 kilonewton. And the final shear force at A will be again at A. Again it will be same. That is 15 plus 10 into 2. That is again 35 kilonewton. Okay, so we have, so how can, so I am drawing this figure here. So here I am having, here it is 0. At this point C, it is 20 kilonewton. Then at C it is 35 kilonewton and again it is 35. So how can I join? Here there is UDL. Here it is a constant. Up to this point it will be a constant. Again like this I can join it. Sorry. Like this I will be able to join. This will be my shear force diagram. Shear force diagram is known as SFD. Sometimes it is written as SFD. So here it will be 20 kilonewton and here it will be 35 kilonewton. So this is the way in which we will be able to understand how to draw the shear force diagram of a cantilever beam. Okay, so I have discussed many problems. So similar problems are also given here. So so here you can understand, here a beam is given and you have to draw the shear force and bending moment diagram. So just understand, this is very easy. You have to just start from this end and it is written like this. Look, at a shear force at D is equal to, what is it? It is 800. At C it will be 800 plus 500. So likewise we can draw the shear force diagram. Okay. So we will the bending moment diagram we will be discussing in the next session only. So just understand how to draw the shear force diagram now. Okay. So this is the way, that is this is a shear force diagram. So the main thing you have to understand is that for a point load, or a constant loads can be of 3 types. Okay, point concentrated load or point load. Then point load, it will be a simple arrow. Then it is a UDL. It is like this. It can be like this or it can be like this. Rectangular shape load. For a point load, the shear force diagram, shear force will be straight. For a UDL, it will be linear. Okay, and in the case of a UVL, it will be UVL. It will be parabolic. Okay, because here you just understand here the shear force is equal to a cone. Here shear force is equal to kilonewton per meter. You are multiplying with that meter. That is the reason why here it is constant. Then it is for UDL the shear force will be linear, and for a UVL it will be parabolic. UVL we will discuss in the next session. Okay. So in this section we have studied about the type of supports, type of beams and type of loads. Okay, and also we have understood how to draw the shear force diagram of a cantilever beam. Only a cantilever beam we have studied. Now we have to study the next you have to study the how to draw the shear force diagram of with a UVL, uniformly varying load. And again next thing will be you have to understand how to draw the bending moment diagram of a of these cantilever beam, then simply supported and overhanging beam. So these will be the things which we will be studying in the next sections. Okay, that's all. Thank you.